We're going to start with the next section of pre-calculus. That is what are called piecewise functions. They're actually known as piecewise defined functions, but that's a bit of a mouthful, so we'll just abbreviate it to piecewise functions as the textbook has done. What they really are is functions defined in separate parts, multiple subfunctions where each subfunction, each part, applies to a different interval section in the domain. If you look at y equals x minus 1, in fact, the absolute value of x minus 1, that's a piecewise defined function. It's a piecewise function because it's over two regions. Consider this, that we say that absolute value is defined as just the contents, the absolute value when the contents is greater than or equal to naught, or in other words, in this case, it's just equal to x minus 1 when x is greater than or equal to 1. And it's the negative of x minus 1 when x is less than 1, where we're changing the sign as the absolute value does. And there's the graph. You're used to doing that. We can define with more than one region from a start. It doesn't have to be a function like absolute value where that occurs. Consider this one here. It's in two sections, y equals x minus 1 if x is greater than 2, greater than or equal to. So to the right of that line, which is x equals 2, that's the critical value for this graph, a critical value. And y equals 1, which will just be a horizontal line to the left of that graph. So there we go. Let's sketch a piecewise function. So if you're sketching a piecewise function, all right, there's the function there, 4 sections to it. Here are the steps. First, determine the critical values. Of course, those are the values over which changes are going to occur. Let's put in dotted lines to represent those, just to make it easier for us to see. Probably better if you put them in pencil, then you can rub them out afterwards, or you can leave them there, in fact. Draw a light sketch of each graph. So there the graphs are y equals 3, y equals 1 minus x, y equals 4 when x is 3, so the point 3, 4, and y equals x minus 5. Don't worry about putting in the axis intercepts and that at this stage, because the sections might not be crossing the axes, so you don't want to have all the intercepts in just yet. We're going to indicate points of exclusion. Now, what we mean by that is where there are points on the graph which aren't included in the graph. If you look at the very first critical value, it's x less than or equal to minus 2. Therefore, we know that the x value at minus 2, the critical value here, the x value is included. So we don't have to worry about that one. That is part of the graph anyway. If we look at the less than 3, we have less than 3, greater than 3 on the lines anyway. So in fact, there's no equal to 3. The equal to 3 is way up there, separate, totally separate section. So therefore, we have to put one of these open dots there where the two lines join. Now we're going to draw the relevant segment of each graph. So we're going to draw the horizontal line y equals 3 to the left of x equals minus 2. We're going to draw y equals 1 minus x. There it is there. Between the two. We're going to put in the dot there, solid dot, for the x values of 3, 4. And we're going to draw the graph y equals x minus 5, but only after x greater than x equal to 3, only to the right of it. So there they go there. Now you notice I have now indicated the axis intercepts at this stage. Let's go on to another section now. That is, given the graph, you have to make deductions from it or work out values from the graph. Now, this is a 5-part one. Phew. Okay. But it's got a couple of things where you have the point -1, 5. There it is there. We have the line y equals 3. Okay. We have the line y equals x plus 3. There. We have the line y equals -2. There. And we have the parabola y equals x squared plus 2 from -1 that way. So you'll notice y equals x squared plus 2 is to the right of -1. Y equals 5 when x equals -1, so that's just a point. We have y equals 3 between -3 and -1, so there we are, -3 to -1. We have y equals 3. Y equals x plus 3 between -5 and -3. There you are. There's y equals x plus 3 there. And then y equals -2 to the left of -5. Now, we could be expected to make a whole lot of different calculations there. Whoops, I don't know what that extra bit is cropped up there. I'm just going to stop there to get rid of it. That's better. Hate to have it looking messy. It won't look messy from now on anyway. And there we are. We have to evaluate those 8 different function values. So remember, if we're determining it off a graph, if we want to find f of 1, we go to x equals 1 and we draw a dotted line to where it hits the graph. So f of 1, there it is there. We're going to go from 1 up to the graph and across to the x value, the y value of 3. So there we are. F of 1 is 3. F of 0, the next one, well, that goes straight up to the y value of 2. So therefore, f of 0 is 2. F of -1, f of -1, it goes to that point, but that's an exclusion point, so therefore it keeps going up to the point -1, 5. So therefore f of -1 is 5. F of -2, well, it hits the line y equals 3 and goes across to 3, so therefore f of -2 equals 3. F of -3, E, f of -3, well, it's still going to hit that same graph. That's an included point there. So therefore it has the y value of 3. So f of -3 equals 3. F is f of -4. And that comes downwards, hits the graph, y equals x plus 3, and goes across to -1. So therefore f of 4 is -1. F of 5, dotted line, oh, that's an exclusion point, so there it goes, and there's actually no point at all. So we're going to say does not exist. F of -6, the last one, f of -6, hits the line y equals -2, going across to -2, and therefore f of -6 is -2. It's rather a busy graph, I'm afraid. But if you're calculating it, you wouldn't have all these labels here, A, B, C, D, E, F, G, H. But you would need to, and also these arrows going down to it, but you would need to have these lines going up, the dotted lines going up to show. and down. You could be required to answer questions similar to this previous one without the use of a graph. Now here is a real humdinger. If you have a look at this one, 1, 2, 3, 4, 5, 6, 7 sections to it. Now I've done that on purpose because I want to show that often it's not the best thing to do to use the graph. You see here, as you will see, considering the interesting shape of the graph of f, the task of drawing the graph will take far more time than evaluation without the graph. Down straight line, then it has the 2 to the x minus 1. There's the point. Then after that we have 2 minus x squared down to there. Then we have minus 3, 2 minus 3, that point. Then we have y equals x minus 4 going up to there, and then we have y equals 1. So we'll take that out, and we'll rather consider them from here. Now what I'm doing is I'm highlighting. What I say is, f of minus 3, which of these areas does minus 3 belong to? Well, it's that one, so therefore it's that function. So all I have to do is substitute minus 3 into that function. And we get 7. If we have a look at the next one, minus 2, well, minus 2 is actually there. It doesn't belong there, it doesn't belong there, but it belongs there because that's x equals minus 2. And when x is minus 2, y is 3. Next one, f of minus 1, well, there we are. F of minus 1 is between negative 2 and 0, therefore it's this function, so I substitute minus 1 into this function, and I get 3. F of 0, well, here's a problem we can see straight away. Less than 0, greater than 0. There isn't any point included that has the value of 0. So that's one where we say does not exist. F of 1. Well, 1 is included between 0 and 2, so we're going to use that function. 2 minus x squared. So it's 2 minus 1 squared, giving us 1. F of 2, well, there it is. It's where it's equal to. That's less than 2. That's greater than 2, but there's equal to 2. So there's the function value, minus 3. F of 3, well, 3 is between 2 and 5. So therefore, I'm going to use that function. And so I'm going to substitute 3 into x minus 4. We get 3 minus 4, which is negative 1. Finally, f of 5. Well, f of 5 actually doesn't belong to this one. It belongs to that one. Oh, it's not finally. It's second to last one. Sorry. F of 5 belongs there because this is less than or equal to 5. So then I'm also going to substitute once again into x minus 4. 5 minus 4 giving us 1. Now finally, f of 6. 6 belongs to this section, x greater than 5. And therefore it's that function, which is just y equals 1. So it's equal to 1. All that remains now is for you to get some practice at these.